thing we want to look for, once we know that x and y are on the same side, is we look for opposites. Where are there opposites in this problem? Comparing first equation to second equation. 11 and 13 are not opposite to one another. The positive 2x and the negative 2x, those are opposites of one another. Okay? If you have opposites, then you're ready to do elimination. Okay? So this one already has opposites on it. So the elimination that happens comes from adding these two equations together. So we're adding the entire equation together. So what's positive 2 plus negative 2? What happens to those? They become 0. They eliminate one another, right? Name of the method is elimination. So these two are opposites, so they eliminate one another. What's positive 3 plus positive 5? 8y. And then over here on the other side of the equal sign, we got 11 and 13. What's 11 plus 13? 24. Now we've got an equation that only has one variable in it. Can we solve that for y? How? Yeah, just divide by 8. Good. So if I divide by 8, we get y is equal to 3. That's an easy second step there, isn't it? That's a one-step equation. If you're doing elimination, you should have one-step equation to solve after you've done your elimination part. Now, we got y. We've got to find x. How do we find x? How did we find it when we were doing the substitution the last couple of days? Take that answer and plug it in, right? So we don't have a nice equation at the beginning where it says y x equals this, but we do have two equations that have a y in them. It doesn't matter which one you plug into. I'm gonna plug into the first one on this one because it has all positives on it, so that makes it a little easier sometimes. Okay, so I'm taking that 3 and I'm plugging it in the place of y. Not plus 11 equals 11. Okay. So 2x plus 9 equals 11. And what do you do to solve that? Subtract the 9. 2x is equal to 2. Divide by 2. 1. Final answer is an ordered pair. 1, 3. So this equation, pretty easy to solve. This one, not as easy to solve, but still not, much more difficult than what we've been doing the last couple of days. So okay. All right. All right, let's do another one here. Example B. Negative 4x minus 3y is equal to negative 2. 5x plus 3y equals negative 2. All right. Are they in standard form? Yeah, both of them have x and y on the same side already, so they're ready to do elimination with. We look for opposites. Where are they at? On the y's. So when I add these two equations together, what's going to eliminate? The y's. So what's negative 4x plus 5x? 1x. Negative 2 plus negative 2? Negative 4. Divide by 1. X is negative 4. We're going to take that and plug it in where? Either of these equations, we're going to plug it in place of x. It doesn't matter which one you use. It will get you the same answer no matter which one you plug it into if you do it correctly. Why would you do the bottom one? Yeah, got a lot of negatives up here in the top, so we got to watch signs a lot more there. So I think Ty's right. The bottom one's a good one to plug into. So 5 times negative 4 plus 3y is equal to negative 2. 5 times negative 4 is negative 20 plus 3y is equal to negative 2. What's the next step? Can't divide yet. Add 20 to get the y part by itself. So yeah, add 20. Good job. Negative 2 plus 20 is 18. Positive 18. Last step. Divide by that 3. 18 divided by 3 is 6. Nice number 6 there. Final answer, remember, is the ordered pair. What's our ordered pair? Remember, X always goes in the front, Y goes in the back. Always. Okay. Not bad at all. (5x plus 6y is equal to positive 4). The y's are going to cancel out. We got eliminations on the y's because they're already opposites. We're always going to add the equations together. Okay, always add the equations. So 5x plus negative 7x. Negative 2x, good. 4 plus negative 8. Negative 4, good. One more step. Divide by the negative 2. X is positive 2 or negative 2? Positive, because you got double negative there. Negative divided by negative is a positive. Okay. What can I do with that? Plug it in. Yeah, I'd go up here to the 5x plus 6y because it's all positives. That's a little, got less things to worry about then. Okay. So 5 times 2 plus 6y equal to 4. Now what? Okay. 10 plus 6y is equal to 4. Subtract 10. Yeah, that's the right thing. Good job. Divide by 6. Negative 1. Ordered pair would be 2, negative 1. Now, the way that you can know that that's the right ordered pair is if you plug 2, negative 1 into this first equation. 5 times 2 is 10, plus 6 times negative 1 is negative 6. So 10 plus negative 6 is 4. If I take that same ordered pair and go into the second equation, negative 7 times 2 is negative 14. Negative 6 times negative 1 is positive 6. Negative 14 plus positive 6 is negative 8. If that ordered pair works in both equations. Okay, so that's how you know it's the right answer to that. It's an ordered pair that works in both equations. Remember, our only options for systems of equations as far as answers are, you got one answer, one ordered pair. You've got no solutions. You don't get an ordered pair, or you've got infinitely many solutions. Those are the three things that can happen. So if we get an ordered pair and it works in one of them, but not the other one, then we've made a mistake somewhere. We need to go back and check and see where we may have missed a sign or misadded, or maybe just wrote something down wrong. So if you get an ordered pair and it doesn't work in both of them, then something went wrong. All right, let's look at the next one. (5x plus 3y is equal to 10). 5x plus 7y is equal to negative 20. Can they? What's positive 5 plus positive 5? 10, not 0. So they don't cancel out. They're not opposites. They're the same number, but they're not opposites. When we're doing elimination, what do we have to have? We got to have opposites. Okay? Opposites are what eliminate one another. Okay? Could I turn the 5x on the bottom into a negative mathematically? How could I do that with a well, if I subtract it, I end up with x and y on different sides. Remember, I got to have them on the same side. What could I multiply the 5x by to make it negative? If I multiply by negative 5, I get negative 25. Negative 1 would change it to a negative 5. But if I multiply one piece of an equation by negative 1, I got to do it to everybody. So I'm going to multiply this entire second equation by negative 1. And that's going to change this problem into negative 5x minus 7y is equal to positive 20. The top one, I'm not doing anything to it. So I'm just going to copy it over. So I multiplied the second equation by negative 1 to make an opposite happen here with the x's. Now my system looks like this. What happens with the x's now? They do cancel out now because they're opposites of one another. So they cancel. 3 plus negative 7, negative 4y, 10 plus 20, 30. Divide by negative 4. So that'd be negative 15 over 2. It's okay that's a fraction. We hadn't had any that have been fractions yet. If you were going to solve this by graphing, it'd be tough to find that spot with a graph because it's in between the grid points. It's not on a nice integer value. Okay, so this is where the solving with the algebra is good because you can find answers like this when they don't cross at nice places. Now, how do I get x? Plug that into the problem. Plug that into one of the problems. I got 3 different problems I can plug it into. I got this one up here, the second one, or this one here. It doesn't matter. I'm going to go to the first one because it doesn't have any more negatives in it, so I'm not making it more complicated. So I'm making 5x plus 3 times negative 15 over 2, and that's equal to 10. All right. 5x minus 3 times 15 is 45. Is equal to 10. 45 over 2. Then what? What do we do next? Yeah, add the 45 over 2. It's a fraction, but we're going to add it to that 10. Can't turn the air on. Have a fan. Pardon? Why can't you turn the air? Because the chiller has been shut down for the year. It's wintertime. So add 45 over 2. So 10 is actually 20 over 2 plus 45 over 2. Be 65 over 2. I'm just getting the common denominator with my fractions there. 10 is 10 over 1, so I doubled both of those to get the 2 on the bottom. Now, how do I get x by itself? Divide by 5. Mathematically, dividing by 5 is the same as multiplying by 1 reciprocal of that. That's going to help us because we got a fraction over here we got to divide into. 1, 13. So 13 over 2. Ordered pair. (13 over 2, negative 15 over 2. You got fractions for answers, and that's okay. That happens sometimes. All right, let's look at another one that we might need to do some work to. 2x plus 5y equals 12. Negative 4x plus 5y equals 6. Couple different ways to do this one, but I think there's one way that's mathematically easier for this problem. Do we have opposites? No. No? We got a 2x and a negative 4x. They're not opposites to one another. Positive 5y and positive 5y. Not opposites to one another. They're close, though. How do we make opposites here? What's one way? By negative 1? Yes. To one of the problems. Yes. Does it matter which one I multiply by a negative 1? No. No. Just got to make one of them a negative 5y, right? So I'm going to pick the second one to multiply by negative 1. Why would I pick the second one instead of the first one? Yeah, it'll turn that negative 4 into a positive 4, and that's easier to add up, right? So that's what I'm thinking there. So that's 4x minus 5y. But it does turn the 6 into a negative, but I think I can handle that because now I'm adding 12 and negative 6. And that's a little easier to do. So now when I add the two equations together, the y's cancel. 2x plus 4x, 6x. 12 plus negative 6, 6. So that means x is what? 1. How do I get y? Plug that in for x. It doesn't matter where I go. I'm going to go to the first one because it looks pretty easy. 2 times 1 plus 5y equals 12. That's 2 plus 5y is equal to 12. Subtract that 2. 5y equals 10. Divide by 5. Minus 2. The ordered pair is 1, 2. So if you've got the same number in front of one of your letters, multiplying by negative 1, great strategy to get you opposites. It doesn't matter which equation you do that with. So you pick whichever one you think's best out of that. Sometimes the top one is better to multiply by a negative 1. Sometimes the bottom one is, but it's a choice. 6x plus 5y is equal to 19. 2x plus 3y is equal to 5. And here we have a couple of equations that are in standard form like we want, but we don't have the same number in front of x and y, or x on either equation or y on either equation. So we can't just multiply by negative 1. That's not going to get rid of anything. Okay? So what could I multiply the second equation by to get rid of the x's? Yeah, if I multiply 2 times 3, I get 6, but that doesn't give me opposites. So what kind of 3 would I need to use? If I use a negative 3, that'll turn that into a negative 6x, right? So I'm going to multiply that entire second equation. Remember, you can't just do one piece. It's the whole equation or none of it. So we're going to multiply this entire second equation by negative 3. That's going to give me negative 6x minus 9y is equal to negative 15. And then the top one I'm not going to do anything to. And I'm going to add those together. What happens to the x's? They cancel out. That's what we want to happen. Then we have 5y plus negative 9y. Negative 4y. Good job. Bless you. Negative 4y is equal to 19 plus negative 15. (19 plus negative 15 to be 4. Last step is divide by negative 4. What's y? Negative 1. How do I get x? Plug it into one of the problems. Doesn't matter which one. I'll go back to one of the originals. Looks like the bottom one has smaller numbers in it, so I'm going to use it. Ends up being 2x minus 3 is equal to 5. Plus 3 to 5, that's good. 2x is equal to 8. Divide by 2. X is 4. Ordered pair. 4, -1. Y goes last, remember? X first, Y last. 4, -1. So here we had to multiply by something that wasn't a 1 so that we could get opposites there. So we multiplied one of the equations by something else. (2x plus y equals -9). 4x plus 11y is equal to +9. A couple of different ways to work this problem, but depends on how big of numbers you want to deal with. And that would eliminate which? The x's, okay. So that would eliminate x's. I think that's a great idea. Keeps us from having real big numbers. What if I wanted to eliminate y's? What could I multiply the top one by? 11? -11. -11 would get us opposites there. But we'd end up with -11 times 9, or -9. So that's 99. It's a bigger number, okay? So both ways will get you the same answer if you do it correctly. I like the idea of multiplying the top one by -2 to get rid of the x's because it's a smaller number, okay? But both strategies would work. So let's do what Hayden said there and multiply by -2 on the top. So that's -4x minus 2y is equal to 18. And 4x plus 11y is still equal to +9. So I didn't change anything on the second equation, just copied it over. Add them up. What happens to the x's? Oh, wait, yeah, they eliminate one another. -2y, +11y, 9y, 18 plus 9, 27. Divide by 9. Y is 3. That's nice. I'm going to go to the first equation for this one because I don't even have to do anything when I plug that in. I just put it in there. It's 2x plus 3 is equal to -9. And then get x by itself. What do we do first? Subtract the 3, right? Be -12. Last step. Divide by 2. -6. Ordered pair. Okay. Let's do simple h. So we had 2x minus 3y is equal to 7x minus 4y is equal to -8. Right. Seven and 2 don't have much in common.
I don't know if I can do this or not. But if you times the bottom one times 2, you get
That would eliminate x's. That would do that. What if I wanted to eliminate y's? What number would I want to change them both into? 12, because 3 and 4 both go into 12. Okay? Either of those strategies would work great. The only thing we need to adjust with Hades is one of those needs to be a negative. It doesn't matter which one. Okay? Same idea with eliminating the y's. We need one of them to be positive, one to be negative. Right now, both of the y's are negative. Okay? Let's eliminate y's on this one, just because we've eliminated x's the last few problems, just so that we can eliminate y's if we want to. So let's turn them both, the 3y and the 4y. Let's change one into a positive 12 and one into a negative 12. What if we want to multiply the top one and get a positive 12 out of that? So I would need to multiply the top one by what? Times negative 4. That's going to change this to negative 8x and positive 12y and then negative 24. So now I need an opposite for that positive 12. 4 times 4 is 16. 3. So I'm going to multiply this whole equation by 3. So that's going to be 21x minus 12y equals negative 24. Then I'm going to add them together. The y's are going to do what? Cancel out. That's what we made happen. We're eliminating that one, and that works out great. Negative 8x plus 21. 13x, good. Negative 24 plus negative 24. Negative 48. Good job. Well, that doesn't work out perfectly, but it's okay. We can have fractions as answers. It's not a problem, because I'm going to divide by 13 to get my answer. 13 doesn't go into 48 evenly, and there's nothing in common between them. So it's just that fraction, negative 48 over 13. That's what x is. That would definitely be one that would be almost impossible to get perfectly correct if you solved it by graphing, like we did the first day that we were doing this. Okay, so that I don't know anybody that could eyeball that, on a graph. It'd be very, very difficult to do. Okay, so this is where the algebra kind of trumps that. So the next thing to do is take that and do what with it? Plug it in. Plug it in. It doesn't matter where you plug it into. I'm going to go to the first one. Because multiplying by 2 is a little easier than multiplying by 7, right? Not a really going to make this problem much easier, but it's a little bit easier that way. So 2 times negative 48 over 13 and minus 3y is equal to 6. So I got a double negative 48 over 13. So that's 2 over 1 times negative 48 over 13. So 1 times 13 is the bottom part. So it's something over 13. And if I double 48, if I double 40, it's what? 80. If I double 8, it's 16, right? So 80 plus 16 is 96. It's negative because it's 40 negative. That's how you do things without a calculator. You break that number down and you think, okay, I'm just going to do the 40 because it's part of 48 and multiply it, and then do the ones digit. That's an 8. Multiply it out, and then add those answers together. That's how you do things. Mental math is what they call it in the younger grades nowadays. They're doing that a lot more than they did when you guys were in elementary school. So, now, what's next? Yeah, I got to add this number over here to the other number. So plus 96 over 13. Not an easy addition to do, but not impossible. 6 is 6 over 1, so I'm going to multiply by 13. So that's going to change into 60 plus 18 to be 78 over 13. I'm just getting the common denominator for 6 and 96 over 13. Now I'm adding those together. So 8 plus 6 is 14. Carry the 1. So 174. It simplifies out pretty nice. Because the next step is to do what? Divide by -3. So when I divide by -3, it's the same thing as multiplying by, which would be -1/3. So that would be y is equal to, now the thing here is look for cross canceling if at all possible. 3, the only factors for it are 3 and 1. 174, I know that's divisible by 3 because 1 plus 7 is 8 plus 4 is 12. 12 is divisible by 3, so 174 is divisible by 3. Okay, so that's the trick for knowing if something's divisible by 3. That also helps you get 6 because 6 goes into that because it's even and it's divisible by 3. So that means 6 goes into it. So I'm just going to divide by 3 here. 3 goes into 17 5 times. 2 left over, that's 24 8 times. So that's -58 over 13. So that works out to be a nice looking ordered pair. -48 over 13, -58 over 13. Okay, so simplifying. Get fractions as answers, that's okay, that can happen. We like for it to not happen, but it does. The world is not built around perfect scenarios. We'll do a couple more real quick. So say we had 2x plus 8y is equal to 10. And maybe we had 2x minus, or excuse me, -2x minus 8y is equal to -4. So their x and y are on the same side, so I don't have to move anything to get it ready for elimination. Next thing to look at is see if we have opposites. Do we have opposites here? Yes. Yeah, got a lot of them, right? The x's have opposites, but so do the y's, right? So when I add these together, the x's cancel and the y's cancel. 10 plus -4 is 6. What's on the left side over here? If everything canceled, what's there? 0. Does 0 equal 6? No, this is false. What was it when that happened when we were doing substitution? If everything canceled out, we had, in a false statement, it was no solution. Those are nice. X plus 5y is equal to 3, and then 2x plus 10y is equal to 6. Do we have opposites? No. Can we get opposites for one of our variables?
Yeah.
Which one? X would be easy. What do I need to multiply by to make that an opposite? If I multiply by -1, it won't cancel with 2. It needs to be a -2 that I multiply by. So if I multiply this top equation by -2, that's going to give me -2x, minus 10y equals -6. The second equation, I haven't done anything to. When I add those two together, what happens? X's cancel and the y's cancel. So what's left on the left side? 0. Everything canceled. What's negative 6 plus positive 6? 0. Does 0 equal 0? Yes, always. This is true. So this is one of those infinitely many solutions. So that's what they look like when those happen.